This is our second lecture of our first chapter, which is building and loading layout, in which in the last lecture we will discuss up to our types of load, and it is already told that in last lecture that in this chapter there is only two main theories are there. First one is types of load, which is covered in our last lecture, and second one is types of load combinations, but these types of load combinations is directly given on our your IS codal provisions. Okay, so in the last lecture we will discuss that there are main three types of loads. First one is vertical load. In vertical load, there is three types of loads are there. First one is dead load, second one is live load, and third one is impact load. This load is based on their acting of force because all the force is acting on vertically downward side. Okay. Second one is horizontal load, and you all know that in horizontal load, there is two loads are there. First one is wind load because wind is always acting on horizontal direction only, and second one is earthquake load, and earthquake is also due to their plate tectonics below the ground level. Okay, and when the earthquake occur, your building will be like this. And last load is longitudinal load, and in longitudinal load moving loads are there. And after this distribution we are discussing that for which load calculations which IS code is preferable. So for dead load you have to use IS 875 part 1, for live load part 2, for wind load you have to use IS 875 part 3, but in your recent syllabus, in your new syllabus, IS 875 part 3, which is revised on 2015. Okay, on earlier days, IS 875 part 3, which is last revised on 1987 is useful, but in your syllabus the IS 875, which is published on 2015, is useful. Okay, so in today's session we will discuss up to our design step of wind load calculations. Okay, now for earthquake load, you all know that IS 1893 2002 is there, but in recent scenario IS 1893 2016 is useful. And for snow load, which is not given but it is also considered in vertical load, is from find out from IS 875 part 4. Okay, so students, let us start our today's session in which we have to find out a design step of wind load calculation. Now you all know that design of wind load on any building is calculated for high rise building. Okay, for low rise building there is another IS codal provisions, and all the specifications are given on that IS code, which is 15498 2004. So it is already discussed that wind load is calculated as per IS 875 part 3, which is published on 2015. Now whenever you have to design any building, high rise building, then you must have to calculate how much wind load is acting on that junctions. Okay, that junction point, which is called as nodal point, and the discussion of nodal point will be discussed whenever we have to start it our example. Okay, so students, in today's session we will discuss that design step of wind load calculation, and this lecture is very important because if you are focusing in your today's session then it is useful in your example point of view. Okay, so now let us discuss our first step. So our step number one, whenever any wind load calculations examples are there, your first step is to find out design wind speed. So Design wind speed is denoted by Vz or Vd. Okay, so what is Vz and what is Vd? So this is the abbreviation of design wind speed. Okay, so now the equation of Vz or Vd is given on page number 5 of IS 875 part 3 2015, in which it is clearly mentioned that the equation is Vb into K1 into K2 into K3 into K4. It means if you have to find out Vz or Vd, then you have to find out five unknowns, which is Vb, K1, K2, K3 and K4. So now let us start our all the unknowns. So first unknown is Vb. So what is Vb? So basically Vb is basic wind speed. So you can see that basic wind speed can be find out from page number 6 and 51. Okay, so you can see that what is VB? It is basic wind speed and it will depend on the location. At which location you have to design for building. Say for example, we have to design a building in Ahmedabad. So you all the students are moved to page number 51, in which it is directly given on appendix A for Ahmedabad. The basic wind speed, which is in meter per second, is 39 meter per second. Okay, but there is some locations which is not directly given in this table. Then we have to prefer a page number 6. So on page number 6, these colorful Indian map are given, and you can see that there is 6 different colors are there. Okay, and for different colors their basic wind speed is given on this table. Okay, so this is our first unknown. Second unknown is K1. So what is K1? K1 is risk coefficient. So risk coefficient will be depend on two values. First one is location. Say for example Ahmedabad, and second one is design life of building. It means for how much year you have to design your building. So generally we have to design any building for 50 or 100 years. Okay, so from table number 1, which is given on page number 7, you can see that your K1 is risk coefficient, which is find out from page number 7, in which there is table number 1. So how to find out your K1? So let us discuss with some example. So say for example our location is Ahmedabad, and we have to design a building for 25 years. Okay, so what is the value of Ahmedabad? So the basic wind speed for Ahmedabad is 39 meter per second. Okay, so you can see that there is a different basic wind speed for K1, in which for Ahmedabad our basic wind speed is 39. Now the design life is 25 years, so you can see that mean probable design life of structure in years is 25 years. So we have to find out our value of K1 from referring this row and this column. So this is intersect at 0.92. It means for location Ahmedabad, and if we have to design our building for 25 years, then our value of K1 is 0.92. Now our third unknown is K2. Now what is K2? K2 is terrain height category, which is find out from page number 8 in table number 2. Okay, so students, you all the students are moved to page number 8, in which there is table number 2, and you can see that on table number 2 there is four categories are there: category 1, 2, 3 and 4. So generally in your exam category is given, but when there is no any clarification regarding categories, then you can see that on page number 6 or 7 there is total four categories. Okay, on category 1 it is clearly mentioned that your buildings surrounding building having height less than 1.5, then it is category 1. If your building's surrounding building height is in the range of 1.5 to 10 meter, then it is category 2. For category 3 is greater than 10 meter, and for category 4 your building's surrounding building is at very closer spacing. Okay, so whenever in GTU point of view there is no any clarification regarding categories, then you have to find out from IS codal provisions. Okay, now you can see that for K2 value, if your value, if your category is given like 3, okay, and your height of building is 30 meter, so for 30 meter and category 3, your answer is not only 1.06, because you all know that with the increasing in the height your wind load is increased, so you can see that coefficient is increased with the increasing in the height. Okay, so you have to design a building for 10 meter, 15 meter, 20 meter and 30 meters. For all the four heights you have to design, and with the increasing in the height we have to design a building depending on your forces. Okay, which will be discussed in our fourth lecture. Okay, now our fourth unknown is K3. K3 means topography factor. Topography factor means on which surface you have to make your building. So there are two topography factors. First one is ground having slope less than 3 degree, and second one is your ground slope having greater than 3 degree. Okay, so if your ground slope is less than 3 degree, then your K3 factor is directly given as 1. But if your ground slope is greater than 3 degree, then you have to calculate your K3 from appendix C, which is given on page number 54 and 55. Now you can see that on clause number 6.3.3.1 it is clearly mentioned that the effect of topography shall be significant at a site when the upwind slope is more than about 3 degree. Okay, if your slope is greater than, then the wind effect is greater obviously, but below that means below 3 degree, the value of K3 may be taken as 1. So that's why we have to taken as 1. Okay, but if your theta greater than 3 degree, then your K3 value is in the range of 1 to 1.36. So this question is generally asked in your GTU Viva, that what is the maximum value of K3? So it is 1.36. If your answer of K3 is greater than 1.36, then you have to assume that there will be some mistake in your calculation. Okay, so now this is your fourth unknown. So let us check how we have to find out K3 from appendix C. So this is your appendix C, in which the value of K3 is find out from the equation 1 plus C into S0. Now, how to find out C and S0 will be discussed in our example. Okay. Now, our last unknown, which is K4. So, students, what is K4? So, K4 is our important factor for cyclonic region. Okay. For cyclonic region where the cyclonic is continuously coming. Okay, so in Gujarat, west coast is generally for cyclonic region. Okay, and the effect of cyclonic region is approximately from 60 kilometer width at the coast. Okay, so this value is given on, you can see that from which page, from page number 9 our importance factor K4 will be find out. So generally our value of K4 is taken as 1. Okay, on seashore where the cyclonic is continuously over there, then we have to take our Value of K4 is 1.30. Okay. So students, after finding out the value of VB, K1, K2, K3 and K4, after finding out all this unknown, we have to find out our first step, which is VZ or VD. Okay, clear? Now our second step is design wind pressure, which is denoted by PZ. Okay. Now first of all, what is the equation of PZ? The equation of PZ is 0.6 VZ square. This equation is given on page number 9. So you can see that design wind pressure is 0.6 VZ square, but this is not your final answer. Your final answer is over here. This is PD, D for design and P for wind pressure. So the design wind pressure is KD into KA into KC into PZ. Now PZ will be find out from this equation. Now our another three unknown, which is KD, Ka and Kc. So our first unknown, which is Kd, is generally is in the range of 0.9 to 1. But whenever there is no any clarification, then you have to take the value of Kd is equal to 1. Now second unknown is Ka. So Ka means area averaging factor. So area averaging factor is depend on tributary area. Now what is tributary area? Tributary area means panel length. It is also called as center to center distance between two columns on both sides. Okay, so center to center distance between panel is called as tributary area. So if your tributary area is less than 10 meter square, then your Ka factor is 1. If your tributary area is 25, then it is 0.9. If it is greater than 100, then it is 0.8. But if your tributary area is in the between range, then you have to find out with the help of linear interpolation. Okay, so this is KD and K. Now the last unknown is KC. So the value of Kc is find out from the close number 7.3.3.13, which is given on page number 16. So you can see that the combination factor is 0.9. Always it is 0.9. Okay. So students, now you can clear of KD, which is 0.9 or 1, K, which is depend on tributary area, Kc is always 0.9 and Pz will be find out from this equation. Okay, so after finding out all the terms, we have to find out PD, which is our design wind pressure. Okay, so students, this is the end of our today's session. In the next session, we have to continue our step number 3, because our step number 3 is very most important step. Okay, so this is the end of our today's session. Thank you.